This says, find the equation of the sinusoid that has a minimum at 10, -20, and a second maximum value at 46, 18. Okay? Well, probably just start by sketching out a picture of this. So we have a minimum up to the first maximum, down to a minimum, up to a second maximum. Cool with the picture I've drawn? Okay. So first things first, maybe we'll figure out our value for k. You could find that by finding the midpoint between -20 and +18, which is what, -1? Or you could do, k max plus k min divided by 2. Either way of thinking about it is fine.
So even though it's like a second max, it's like you still use the same equation?
That's not going to change that part of it. So like 19 units in between those. So that also tells me the amplitude, right? Or you could do the distance between the two divided by 2. Right? Either way of thinking about it is fine. Is everybody okay with what I'm doing there? Rita?
Yeah.
Okay. So next thing I'll do is figure out the period. Well, if I look from here to here is 1 period. And then there to there is another half. So I know 3/2 periods, 1.5 periods, is going to equal the distance from 10 to 46. So if I multiply, oops, that's not how you spell period, Mr. Kulik. If I multiply both sides by 2/3, I get the period is 24. To solve for c, then c is going to be 12/pi or -12/pi. Is that okay? And now all I need to do is write or figure out my h. So which type of function would I want to use for this, sine or cosine? Yeah, because I know I have mins and maxes. So I'm going to use cosine. So I'm going to take the point 0, 1, which is a maximum, and I'm going to map it to either point. It doesn't really matter. I'm just going to use the first one that's listed there, which is the minimum. Since we're going from max to min, what does that tell me? A is negative. Very good. So the A that I need then is -19. And then the h value, since the x-coordinate for my parent function is 0, the x-coordinate for my transform function should just be h. That's everything I need. So I can say y equals -19 cosine of 1/12pi times x minus 10 plus -1. And you could simplify that a little bit if you wanted to, but this is fine. Is that okay, Rita?
Yeah.
So this is probably the trickiest piece here, the period. And I don't know how you would expect to get that without drawing the picture, which is like really kind of important. Elena?
Okay, so in the key it says 2/3, but obviously it's 3/2 of a period. But then when I multiplied 36 by 3/2, I got 54.
Right. So I think probably what it says is period is equal to 2/3 of like 36,
Yeah.
which is the same thing that we did over here because we multiplied both sides by 2/3. Right. So one period is 2/3 of the distance traveled. So it's the same thing. It's just like I showed my work in a strange way, I guess, or whatever. But it's doing the same stuff. Is that okay? Okay. Jamie.
I'm Carmen.
Carmen, shoot. Your
It's
sister.
Okay. It's okay.
She sits, I think, in the exact same seat almost,
Yeah.
which is doubly confusing.
It's okay. How do you know whether the equation you're writing is sine or cosine?
So you have a choice. You can choose to do either one. Now, in a problem where I'm given extrema, I would use cosine. In a problem where I'm given like midline points or midpoints, I would do sine. Because it makes finding the h easier. Because you can map up a point whose x-coordinate is 0 in the parent function to the given point. Does that feel okay? And that's an important question, right? Like knowing which one to use that makes life easier is super helpful. Giselle?
Page number 10 on the book pages.
Sure. So it says identify the vertical and horizontal shift for the function. Well, that part's pretty easy. So we'd be left pi over 4 and then down 2. Cool with that? Says then graph the function on that interval from -4 pi to 4 pi. All right. So we'll write our transformation map. Oops. And I'll take my points from cosine. Mr. Kulik, where are these coming from? I'm just copying them down from the reference point sheet that I gave you guys in the content library. How are you doing it so quickly? I don't even see you looking at it. Well, I've been doing this for like 15 years, so you just memorize them at some point. So if I plug this through, I have 0 minus pi over 4. That just becomes negative pi over 4. 1 minus 2 is negative 1. Pi over 2 minus pi over 4 is positive pi over 4. 0 minus 2 is negative 2. Pi minus pi over 4 is 3 pi over 4. Negative 1 minus 2 is negative 3. 3 pi over 2 minus pi over 4 is 5 pi over 4. 0 minus 2 is negative 2. And 2 pi minus pi over 4 is 7 pi over 4, when 1 minus 2 is negative 1. So those are my values. So let's see, I have to go to 8 pi, or 4 pi, excuse me. And I'm going to go, each tick mark is going to be a quarter. Okay, so I'm going to need 16 tick marks on the left side. So this would be negative 4 pi. That'd be like negative 3 pi. I'm going to write them above so they're out of the way. Negative 2 pi. Negative pi. And then that would be like the y-axis. Do the same thing over here. God bless you. All right. And now let's start plotting. So negative pi over 4, negative 1. Positive pi over 4, negative 2. 3 pi over 4, negative 3. 5 pi over 4, negative 2. And then 7 pi over 4, negative 1. So like that's that part. And then I'm just going to continue my pattern in both directions. So midline point, minimum, midline, maximum, midline. And in the other direction, we'll go midline, minimum, midline, maximum, oops, too many, maximum, midline, minimum, midline, maximum, is that cool?
Yeah, thank you.
Yeah, that was a long one. Going from negative 4 pi to positive 4 pi. Woo! Got lengthy. Anybody else? Seen a graphing, we've seen a write from the words. Okay, cool. Today then, we're going to start section 3.2 then. Yeah, it was all 3.1.
How many sections are there?
3. 3.2 then is going to be doing the same thing, except we're going to be using tangent. Tangent. You did sound really sound confident. Oops. All right. So, reminder again, how do I find tangent on the unit circle? So for any angle, the value of tangent is going to be y over x. So tangent of 0 is 0 over 1, which is just 0. Tangent of pi over 6 is 1/2 over square root 3 over 2, which is 1 over the square root of 3. I forget the decimal approximation for that. What is it? It's like something. 0.57. Tangent of pi over 4 is root 2 over 2. Divide by root 2 over 2. Oops. Tangent of pi over 3 is going to be the square root of 3 over 2 divided by 1/2, which is the square root of 3, which is 173. And then tangent of pi over 2 is going to be 1 divided by 0. What's that? Undefined. So what's going to happen here?
A whole.
Not a whole. We're going to get a vertical asymptote. You were close. You were right. There was a discontinuity. You just picked the wrong kind of discontinuity. That's okay. So tangent of 2 pi over 3 will be root 3 over 2 divided by negative 1. So that's negative root 3. And then this is negative 1. And then that's going to be negative 1 over root 3. Well, I did the same decimals that we did before. I plugged them in a calculator one time and just, it's going to be the same values over and over again. So I'm just reusing them just with the appropriate positive and negative signs. Tangent of pi is going to be 0 over negative 1. Tangent of 7 pi over 6 is going to be negative 1/2 over negative root 3. Well, that's positive 1 over the square root of 3, or 577. And then that's going to be 1 root 2 over 2 divided by root 2 over 2. And then we have negative square root 3 over 2 divided by negative 1/2, which is just negative root, which is going to be root 3. And then if we get down to here, what's going to happen? Negative 1 divided by 0. So what do we get? Nope. Another asymptote. Whoa. Okay. 5 pi over 4 is going to be negative root 3 over 2 divided by negative 1/2, which is just negative root 3. And then that's going to be negative root 2 over 2 divided by root 2 over 2, so that's negative 1. Oops. Those were in the wrong places. My apologies. Hold on real quick. Okay. There you go. Now, what are we doing here? There. What is that point doing there? I don't know. Anyways, we'll come back to it, I suppose. And then this is going to be negative 577. And that'll be 0 again. What is this stupid point doing here? Where is that at? That shouldn't be there. Very confused. You, Mr. Point. I don't know why that's there. It shouldn't be there. This guy right here, go away. Why are you here? I don't have anything at 3 pi over 2 on my list anymore. Why is that still there? It's making me really angry. I don't understand why it's there. I apologize. You need to ignore it. It's invisible. Pretend you can't see it. Go away! All right. So what are we noticing here? There's the graph of tangent. Whoa. It is a little kooky there, huh? A little kooky. Notice that we're getting a asymptote. How far apart are these asymptotes? We saw one at pi over 2, another one at 3 pi over 2. They're pi apart, right? So I should have one at negative pi over 2 and negative 3 pi over 2. Let's make them all the same color, right? So what's the period for tangent? It's pi. Yeah, you're right. Well, that's kind of weird. Yeah. Well, I mean, like, not for transformations, because those can change, but like the fundamental period for tangent is pi. Yeah, absolutely. Where's the midline at? Yep, y equals 0. Still the midline, right? I'll have the equal amount of the graph above and below it. That's good. The period's pi, so the frequency must be 1 over pi, right? What's the amplitude? What did we say the amplitude was? Good, the distance from the extrema to the midline. Is there an amplitude here? No. Are there any extrema in this graph? No, because we have arrows pointing up and down, so there are no, and the graph is increasing the entire way, right? As you move from left to right on the continuous pieces anyways, it's always going up. So what is, like, how is the A affecting things then? Oh, well, it definitely does. That distance there is kind of like taking the place of our amplitude. Yep, the middle dot. That's pi over 4, 1 is what that point is. Notice, where is that? That's like halfway in between 0 and like the midline point and then the asymptote. That's the spot that's halfway in between. So if we did the same thing over here, that point's going to be kind of, or that distance is going to be kind of like the amplitude. Is everybody okay with that? It's kind of tough to see. No, but when you're going to write the equation from the picture, that's the thing that kind of contributes the A value, is looking for that distance, so it acts kind of the same way as the amplitude does. But no, this has no amplitude. But this is kind of like our value for A. Maybe I should put that instead. So if I guess I didn't say it explicitly, but in section 3.2, all we're doing is the same things we did in 3.1, just with tangent instead of sine and cosine. So it's the same processes. We just have a new function that we're doing this stuff with. Jalika. Sure.
Wait, so does it say the amp is pi over 4?
What?
So it's pi over 4 is the amp?
No, just 1 here. because it's a vertical distance, right? If I track that over, that distance is 1.
Which is the y of the middle of that.
Oh,
Sure. Assuming that the midline is at 0. If the midline's not at 0, Sophia, then no. That's okay? Okay. Okay. What's the period, or what's the domain going to be on something like this? No.
we're having a lot of breaks.
Yeah. Yeah. How do I write that? Right? How many breaks does it have in its domain? Infinitely many. Yeah. How do I write that? Here's how we're going to write that. We're going to say all real numbers except for, and then where are these asymptotes occurring? They're at
every whole number.
So this one here was at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2.
And pi over 2.
Where
No, because that's so smart of me.
where n is, what does n have to be? Odd, right? 1 pi over 2, 3 pi over 2, 5 pi over 2, negative 1 pi over 2, negative 3 pi over 2, negative 5 pi over 2. Those are all odds.
But you say 1.
Says does not exist.
Oh.
DNE. I think that's more laughing at my penmanship there.
I was like, why do you spell out what?
We'll put some periods next to the letter so it can tell it's an abbreviation. With all caps as well is a weird way to spell it. Spelt 1 all caps?
I thought you were just trying to be like unique with it. I don't know.
Yeah, no.
Don't want to talk about it.
What's the range gonna be? Yeah. The range is all real numbers here. Notice that we have an arrow pointing down, an arrow pointing up, and it's connected in between them. That covers all the y's for us. So what if we talk about the transformation then of this? What's the period going to be here? Very good. What's the midline going to be? Yeah, why isn't it not 2 pi? Because the fundamental period for tangent is just 1 pi. Because it's different than sine and cosine. Okay. What's the midline? For the transformation? Okay. Yeah, it'll be the same as before. We're just going to be shifting it up. That'll just change the midline or down. So we talked about what the absolute value of A did again, right? Where it's just changing that distance from the midline point. Or if you look at the point on your graph between the midline point and the asymptote, the distance between that point is the absolute value of A. So if the A was 5, that point would be like, like taller, right? If we do like y equals 5 tan x, that's probably a bad decision, but we'll do it anyways. So if I take, oh boy, this same point and I trace it, oh jeepers creepers, Mr. Kulik, you're just really making this a mess. All right. Okay. So if I trace up from this point onto here, that point should be pi over 4 comma 5. Should be 5 units up from the midline. Here, just to show you. Oops, I meant pi over 4, dummy. See? So it's just this point has been shifted up or been stretched up 5 units, right? So the distance between this point and the midline is now 5, right? This point here and this point here are on the same vertical line. They're both at pi over 4. Okay. Here's the toughie now. Well, not this. This was easy. I just forgot to write it down right away. What's the domain going to be in the transformation? No.
Oh, we're at
No.
X, anything but n over 2.
So here's what I would do. I would say, okay, I know that one of the asymptotes starts at pi over 2, right? I could shift that with my h so it could be in a new location. And then the next one, instead of occurring every pi units, would occur pi over c units, and as many of those as I needed to.
Repeat that. Sorry.
So if I look at tangent, I have an asymptote at pi over 2, right? Yes. We'll write parent function. I'm trying to explain this, if we were confused. In the resultant function, that asymptote could be shifted left or right. What shifts that? The h, right? In the parent function, the next asymptote would occur pi away at 3 pi over 2, correct? That's one period. Here, though, the period is possibly transformed, right? So it's going to be plus the new period, pi over c. And every time I add a period, I would get a new asymptote, right? This is just what we're seeing from the original. So how do I add more than one period? I just put like a variable there, n, and I just say, okay, n has to be some kind of positive or negative whole number. It has to be an integer. That's like a z with like a double bar in the middle. That's the symbol, set symbol for the integers. Did we not talk about this already? No. We didn't do this before? I'm sorry. That's just the symbol for the integers. You could write in words. You don't have to use the symbol. That's okay. Because if I add 2 periods, I should be at another asymptote, right? If I had 3 periods, if I subtract 7 periods, all of these should land at another asymptote, right? That's a little tricky there. All right, so let's look at an example here. Let's say we have the function, do we have negative tangent of x over 2? First thing I'd want to do, if I'm dealing with anything with this, is identify the values for a, c, h, and k. What's my value for a? What's my value for c? 2. What's my value for h? 0. And what's my value for k?
0.
All right. So if I want then my midline, what's the midline at?
0.
Y equals 0. Remember, Mr. Kulik's going to be picky about that. If you just write a number there, he's going to mark you down. It's an equation for a line.
I'll keep that in the old thing box.
What's the period going to be?
2 pi.
Good. Pi times the absolute value of c, so just 2 pi. Great. What is the what's the domain going to be?
All the numbers x can't anything but pi over 2 plus 2 pi. So
N. Very good. I've been writing it as you've been saying it.
Should we tack on that a little bit at the end every time we write the domain?
You have to say what n is. Because if n is not a whole number, then that's not right. You know what I mean? What's the range?
all the numbers.
Yeah, it just stays the same.
What if you pay for all like all the numbers in the text?
Depends what the directions say. Depends what the directions say, whether it asks for intervals or whatever. You know what I mean? It just, that's still the right answer. It just, whether it follows the directions or not kind of question. You know what I mean? Okay, what if we want to graph this now? If we're going to graph this, we need to use the transformation map. Is this something you should have memorized?
Yes.
100% yes. So for us, that is going to be 2x minus y is our map. And then what are the reference points that we're going to use for tangent? Well, I'm going to go to my reference points sheet, look up tangent, and copy those down.
Just the first five? Or?
Yep, just the first 5 is enough. Oops. What does UND stand for? Yeah, very good. Okay. Negative pi over 2 times 2 is just negative pi. What's negative of undefined? Still undefined. Negative pi over 4 times 2 is negative pi over 2. And then negative of negative 1 is positive 1. 2 times 0 is 0. Negative of 0 is 0. 2 times pi over 4 is positive pi over 2. Negative of 1 is negative 1. 2 times pi over 2 is pi. Negative of undefined is still undefined. So let's say we wanted to graph this from negative 2 pi all the way out to positive 2 pi. I would say here each tick mark could be pi over 2. So that's negative pi. There's 0, positive pi, positive 2 pi. So if I'm graphing here, I have negative pi undefined. When you're graphing, should you put an asymptote in there, like that dashed vertical line? Yes. Negative pi over 2 and 1 is here. 0, 0 is there. And then positive pi over 2, negative 1 is there. And then I have an asymptote. So I'll draw in my piece. And then I'm just going to fill in the other space. And that'll do. What do you guys think on that? Is that okay?
Yeah.
So it's still basically the same thing, right?
Yeah, just the 2 pi 0.
Huh?
Like on like 2 pi 0 over there.
I just followed the pattern. So this should be like dashed or whatever. I just forgot to dash them. Right? Like, come on. This section and this section were the dash sections. I just forgot to write them dashed. I just got excited. And the tangent graph's a little bit more challenging to draw nicely, especially if you're dashing it. You know what I mean? Maybe you don't. You haven't drawn a lot of them yet. Getting it to curve and look like it's kind of curvy and not just like a straight line is sometimes a little tricky.
How did you know that your asymptote was
At where?
like negative pi?
Because undefined.
Oh.
Undefined tells me where the asymptote is. Yeah, good question. Right? That's certainly important. Like Mr. Kulik, should I be putting the asymptotes? And it's just where the function is undefined.
I see it.
All right. What if I want to write the equation from the graph? Okay. So just like before, what do we like to start with?
Midline.
Midline. Where's the midline at?
One.
Right. Right.
-1.
Yeah, right here. Is everybody okay with that? Are we okay? Next, let's find the amplitude, or the A value. I guess it's not really the amplitude here. So notice I've given this other point in between the midline point and the period. What do you suppose I'm going to be using that for? Yeah, figuring out the A. So how far is that distance? That's 1 unit, right? So the A is then either 1 or -1. Everybody's okay there? How do I find the period? It's just the distance between the asymptotes, right? So if we go from -π/4 to +π/4, 1 period is π/2. So that's pi c equals π/2. So clearly c has to be then 1/2 or -1/2. Just like before, we're always going to assume the c to be positive valued. Sophia.
So, like, if we were to do like a formula for this, like we would just like 1 period equals pi/2. Like that's definite. Like we're gonna use it every time.
No, the π/2 came from up here. I measured.
Oh.
The distance from -π/4 to +π/4 is π/2 units. I counted, right? That's how I got the π/2. That's not standard. That's just from this specific picture. Does that feel okay, Rita?
How do you know it's for like the A, like what point to like connect it to?
It's always the in between the midline point and the period, or in the asymptote.
Okay.
So you just pick the point in the middle of those two things, and that's what you're measuring back to the midline. And it doesn't matter whether you're looking at, on the left side of the midline point in the asymptote or the right side, it doesn't matter. It's because it's just a distance, right? So you could have looked at the other one. It's doing okay? So far, so good? All right. The last step, we need to figure out the sign on A and the value for H. We do this the exact same way we did before. So which point from the parent function do you suppose I'm going to choose? 0, 0. And we're going to map that up to the point on my resultant function, which is 0, -1. So what I have to remember is when I looked at my graph of tangent, does it go down, midline up? So down, midline, up. Here we're going down, midline, up. What's that tell me then? A is positive. And since the x-coordinate from our parent function is 0, the x-coordinate in our resultant function is h. So that tells me that A has to be +1 and h is 0. And I'm all done. Is this really any different than the things that we've done before? It's like the exact same stuff, right? This is where I wanted to stop. That's all of 3-2. That's enough. Right? You guys should be able to do now problems 15 to 26. You should be able to do worksheet 4, but I only want you to do 2, number 2. Yeah. And then on worksheet 5, I only want you to do 5 and 7.
Got that.
No, when would these be due? Yeah, so like, what's that going to be, like the 14th, 19th or something? This Sunday's the 14th. No, is the 9th, 16th. What's going to be due this Sunday?
Worksheet 14,
1, 2, 3, and then
1 to 14, worksheet 1.
Yeah, 1 through 14 worksheets, 1, or what, 2, 3, and what were they?
1, 2, 3.
1, 2, and 3. There you go. Something. Everybody's okay?
Yep.
All right, cool. We'll stop here.